Changing from standard form to factored form. This is also called factoring. So first we're going to start off by looking at common factoring, and we have 3 steps that kind of guide us through this process. And the first step is to check for a greatest common factor, or a GCF. The second step is to divide that number out of all of the terms, and the third step is to write the remainders beside the divided out / factored out number in brackets. So we're going to do our example A down below by following all of those steps. So the first step is to check for a greatest common factor. So we are going to focus on looking at the 6 and the 9. So we are going to write down lists of all the pairs of numbers that multiply together to give us 6, and then all the pairs that multiply together to give us 9. And by doing that, we're going to be able to get all of the factors, so all of the numbers that divide into 6 or divide into 9. So we can do 1 times 6, and that gives us 6, and 2 times 3 gives us 6. And so 1 and 6 and 2 and 3 all can divide into 6. Let's do the same thing for 9. So 1 times 9 and 3 times 3. So now that we have all of the factors for 6 and all of the factors for 9, we want to figure out what is the greatest one that is common between the two of them. So what's the biggest number they both have in common? Well, that is 3, right? That's the biggest number there. So that is going to be our GCF, or greatest common factor. Now, I wrote some lists here, and you can do these lists in your head, or you can use your calculator to help you to generate these lists by using trial and error. So now that we found our greatest common factor, we are going to divide that number out of all of the terms. So we have our equation y is equal to 6x squared plus 9. And 6x squared is one term, and that plus 9, that positive 9, is another term. And we're going to divide that number out. So we are going to start off, though, by writing that greatest common factor, that is 3, in front. Okay, so this is the number we are dividing out or factoring out. And now in the brackets, okay, so then we're kind of doing 2 and 3 together because they go together. So we are going to be dividing 6x squared by 3. Okay, so 6x squared divided by 3, that's going to give us 2x squared. So right at the front of the brackets here, we're going to write 2x squared. Now for our next term, which is positive 9, we are going to divide that by 3, and that gives us 3. So our second term in the brackets is going to be plus 3. And let's just fix this up a little bit. Our bracket's hanging out there. There we go. So we are all done. We're factored. So when we are factoring, we are taking like an equation or a relation that has separate terms, and then we want to make them all look like they are multiplied together, which is what it looks like in this case. So this here in the red rectangle, this is your final answer. This is your final factored answer. We've gone from standard form to factored form. Now, that was a fairly simple one. So a lot of the time we want to actually do what we call trinomial factoring. And so this is a bit different from common factoring. So when you have a trinomial, and here's our trinomial form right here. So y is equal to x squared plus bx plus c. And we're only doing cases where a is equal to 1. So we are just not going to put it in there for now because it does not need to factor into this method that I'm showing you of factoring. So when we do trinomial factoring, we need to find 2 numbers that add to b, so here's b right here, and multiply to c, and this helps us to factor it. So what we do in this case is we identify b and c first, and here's our example. Y is equal to x squared plus 7x plus 12, and we have b is positive 7 and c is positive 12. Okay, so we've identified b and c. Now we need to find 2 numbers that add to give us 7 and multiply to give us 12. There's different ways to do this, but the method that I've shown you in class is to take your C number, here it's positive 12, and then write down all the pairs of numbers that multiply together to give us C. So 1 times 12 gives us 12, 2 times 6 gives us 12, and 3 times 4 gives us 12. So once we have all of those numbers, and again, you can do that in your head on your calculator, we need to check and figure out which pair is going to add together to give us 7. Okay, so we're going to try that out for each of these pairs of numbers. So 1 plus 12, that gives us 13, so that's not 7. 2 plus 6, that gives us 8, also not 7. 3 plus 4, okay, this one gives us 7. So 3 and 4 are the numbers that we are looking for. Oops, I went right on top of the 7 there. Let's do it in red. Okay, so now that we've found those numbers, we can actually go straight from our standard form to our factored form, and we don't need to show a bunch of calculations in between because we've already done our calculations. So what you want to do is you want to actually set up your equation like this. Okay, so y is equal to open bracket times open bracket. We are going to take x, or whatever variable you have, you're going to put it at the front of the bracket. In the back part of the bracket, you are going to take your two numbers that you just found. So we have a positive 3 and a positive 4. So we have x plus 3 and x plus 4. And we are all done. We are all factored. Y is equal to x plus 3 times x plus 4. So some of you will not need to do all the steps that I've done at right with the whole list and everything, because some of you will just do it all in your head, and that is fine as well. What's important is that final factored answer there that I have in the red rectangle. So let's keep going with a few other examples. So we have y is equal to x squared minus 2x minus 24. B is equal to negative 2, and C is equal to negative 24. So we're going to take that negative 24 and we're going to do a list of numbers that multiply together to give us negative 24. Now I like to start with my whole list having just positive numbers, and then we're going to play around with the negative sign afterwards. So 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay, so right now we have the case though where our pairs of numbers multiply to give us a positive number, but we need a negative number. So what we need to do is we actually need to play around with our negative signs. So I'm going to start off with 1 times 24, and I'm going to say, okay, well, what if we had a negative 1? Okay, so negative 1 times 24, that gives us negative 24. And now, if we have a negative 1, though, we need to check and see if this is going to add to negative 2. So negative 1 plus 24, okay, that gives us 23. So definitely that's not negative 2. Now, what you want to do is you want to try it the other way. Well, what if this is a positive 1 and a negative 24? Okay, let's try that one. So positive 1, negative 24. They multiply to give us negative 24, but they are going to add to give us negative 23. So that is also not negative 2. We go down our list, and our answer is going to be actually right here at the bottom. So if we have a positive 4 and a negative 6, these two numbers are going to add to give us negative 2. So positive 4 plus negative 6, that gives us negative 2. So right here, we have the numbers we want, positive 4 and negative 6. Okay, so we are going to do what we did in the previous one. We have our skeleton or empty brackets multiplied together, put x in the front, and now we need to put the numbers that we found in the brackets as well. So we have a positive 4 and a negative 6. And we're all done, we're all factored. You can always do a quick check once you have your numbers there and actually just check it again. You know, positive 4 times negative 6, yep, that gives us that negative 24. And positive 4 plus negative 6, that gives us negative 2. So here's our final answer. Okay, let's keep going because I know that doing these number lists and sometimes when we add in the negative sign, it makes it difficult for people. So we're going to do some more. Okay, D. Y is equal to x squared plus 3x minus 28. So our value for B is positive 3 and our value for C is negative 28. So we're going to take that negative 28. We're going to start off with a list of positive numbers. So 1 times 28, 2 times 14, and 4 times 7. So remember when we're writing this list, we're actually finding all of our factors of that number as well. So right now, everything is positive, but we know that in order to get a negative 28, one out of the pair needs to be negative because a negative times a positive gives us a negative number. So you can play around with the negatives and the positives as we did in the previous example. And when you do that, you will end up down here at the bottom, hopefully, with the 4 and the 7. So if we make this a negative 4 and a positive 7, they multiply together to give us negative 28, and they add to give us positive 3. So y is equal to x minus 4 times x plus 7. Okay, one more example. So we have example E here. Y is equal to x squared minus 1x minus 20. So B is negative 1, C is negative 20. And we're going to do our list with that negative 20, but starting off with all positives. So 1 times 20, 2 times 10, and 4 times 5. Because it's a negative 20, we need to go through our list though and play around with having one number be negative and one be positive. And once you've done that, you should end up at the bottom here where we have a positive 4 and a negative 5. So those two multiply together to give us negative 20 and add to give us negative 1. So our factored answer is y is equal to x plus 4 times x minus 5. And it does matter where the sign goes because we need to have a negative 5 in order to get this negative 1. If we get a negative 4 and a positive 5, that would give us a positive 1 when we add them together. So it's important to keep the signs correct. So sometimes we need to common factor and trinomial factor together. So we're going to do 2 quick examples of that. And some of you might not even need to watch all of these examples, but factoring is usually what people have the most difficulty with, so I figured I could not do too many. So what we're going to be doing is we're going to be checking for common factoring first. So we have 2x squared, 16x, and 24. Now we could go and write out our lists for the greatest common factor, so to get all of our factors. However, our greatest common factor cannot be bigger than our smallest number, and our smallest number in this case is a 2. So our greatest common factor is 2. So we are going to common factor out a 2 as our first step. So we write the 2 in front, and then we're going to open up a set of brackets. So the first term in the set of brackets is going to be the result of 2x squared divided by 2. That is going to give us x squared. The second term in the set of brackets is going to be the result of 16x divided by 2. Right, so here's our 16x, dividing it by 2, and that is going to give us 8x. And lastly, we have 14x, or sorry, not 14x, we have 24, don't know where 14x came from, divided by 2, and that is going to give us positive 12. Okay, so here we've done the common factoring bit. Now we are going to do our trinomial factoring. So our B value is 8, and our C value is positive 12. So we're going to take our positive 12, we're going to do our list with that. So we've already done this list before, so hopefully it'll get faster the more you do it. And we need to figure out which two numbers add to give us positive 8. That's going to be 2 and 6. So now we can finish factoring. So y is equal to 2 times x plus 2 times x plus 6. So this here is our final answer. And it's very important that when you're common factoring something out, it doesn't disappear. A lot of people think, oh, it's going out, I'm getting rid of it. But this 2 needs to stay here. It's very important. Let's do one more. So for G, we have y is equal to 3x squared minus 9x minus 30. As I just said before, for our greatest common factor, because we're going to check for common factoring first, and in this case, yes, we have it, it can't be any bigger than our smallest number, and our smallest number is this 3. So our greatest common factor is equal to 3 for this question. So we are going to common factor out a 3. So 3x squared divided by 3 gives us x squared. Negative 9x divided by 3 gives us negative 3x. And negative 30 divided by 3 gives us negative 10. So we've done the common factoring part. Now we're going to get on to the trinomial factoring. So let's identify B. That is negative 3. And C. So C is negative 10. So we're going to write our list of numbers. So 1 times 10. And then 2 times 5. It's a very short list. So we only need one of each pair to be negative in order for them to multiply and give us negative 10, right? So negative 1 times 10 would give us negative 10. So if we go down to 2 and 5, we're going to make 5 negative, okay, because 2 times negative 5 gives us negative 10. And 2 plus negative 5 gives us negative 3. Right? So 2 plus negative 5 is equal to negative 3. And that's our B value. So those are the two numbers we are looking for. So your final answer will be y is equal to 3 times x plus 2 times x minus 5. So lastly, we're going to do factoring using a difference of squares. And for some reason, whenever I make this into a PDF, the title ends up on the bottom. So I rewrote it here. So factor using a difference of squares. So what we're looking for is the pattern a squared minus b squared. And then we can factor that into a plus b times a minus b. And this can only happen when you can write two terms as squared with a subtraction sign between them. So very important that you have that subtraction sign. Otherwise, we can't do a difference of squares factoring. Okay, so subtraction and difference, those mean the same thing. So let's take a look at our first example. We have y is equal to x squared minus 16. And we want to see if we can write this as something squared minus something squared. So our x squared, that's already something squared. Now, what about 16? If you're not sure if you can write 16 as another number squared, what you can do is you can take the square root of it. So if I take the square root of 16, that gives me 4 exactly. So this tells me that if I write 4 squared, this will be equal to 16. So I'm going to now rewrite y is equal to x squared minus 16 as y is equal to x squared minus 4 squared. Okay, so now we have it written as something squared minus something squared. And that looks like a squared minus b squared that we see up above. So to write it out as factored though, we would then follow the pattern up in red up above here, right? The a squared minus b squared is equal to a plus b times a minus b. In this case, your x is representing your a, and your 4 is representing your b. So we have x plus 4 times x minus 4. Okay, and then we're done, and we are all factored. Now, sometimes you do have to common factor first. So before factoring using a difference of squares. So we're going to look at that case here. So we have y is equal to 3x squared minus 75. So when we're doing the common factoring, remember we are looking for our greatest common factor, the GCF. And the GCF cannot be larger than the smallest number. And the smallest number we have here is 3. So in this case, our greatest common factor is going to be 3. So we are going to common factor out 3, and we end up with 3 times x squared minus 25, because negative 75 divided by 3 gives us negative 25. Okay, so we've done the common factoring. Now we need to see, can we write this as something squared minus something squared? And I mean this part here in the brackets, right? We have the x squared already, but what about that 25? So we're going to take the square root of 25, if we're not sure. That's going to give us 5. So that tells us that we can write 5 squared, and that is equal to 25. So y is equal to 3 times x squared minus 5 squared. So now we have that situation where we can see that pattern of a squared minus b squared, and now we're going to factor it into a plus b times a minus b. Or in this case, we're going to be using our x's and our 5's. So y is equal to 3 times x plus 5 times x minus 5. And that is our final answer.